All right, so database schema design is something that is definitely can be challenging. Again, creating a correctly designed database is something that you guys should get better at. Again, the reason you want to spend the time up front is because once you get your database settled, it's usually harder to alter your data in your database after you kind of get your application up and running. So let's talk about database schema design, how we want to kind of design our databases. So first, just backing up just a little bit, why do we need databases? So we talked about this a lot. Jake and Jack talked about many benefits of databases, but we want to persist data between instances of our application, right? So if we have, application where a user enters their name and maybe their credit card information, we might want to give them the option, hey, we can remember your credit card information for you. And so the next time they log on, they shouldn't have to keep entering their credit card information over and over again. We have that stored, say, okay, you've logged in successfully. We have your credit card information, so you can use that right away. Also, to share data between applications. So this isn't something necessarily that we're going to use in our cohort, but you can imagine maybe you have like an administration application and like a client-facing application. Your admin app might be dealing with creating user accounts, managing user accounts, and then your client-facing one would be what your users actually use. Like if it's Amazon, maybe they make purchases, they have order information, and so forth. But if I'm like an employee for Amazon, well, I might also have my own application that works the same data. For example, let's say a user says, "Hey, I forgot my password. Could you help me log in?" Well, maybe my application lets me reset the password, so it's going to actually modify the database so that the user can enter in a temporary password. Again, there's many ways that password retrieval exists, but just know that multiple applications can access the same database, even though the applications are doing different things with the data. Updating, and we saw this working with CSV files, not the best mechanism or medium for updating data, but databases handle it kind of really effectively, especially when you have millions of records. You don't want to be updating a CSV file. It's going to be a slow operation, not the proper way to kind of store data. And then something that's really important, kind of baked in, is security and data integrity. Again, something that CSV files don't offer. Right, CSV files, for the most part, they're just text files, right? You can enter whatever data you want. It's a responsibility of your application to make sure that the data is correct. Databases, however, just add another layer where your security and data checks can exist, so that your application doesn't necessarily need to do it all the time. But in speaking in the real world sense, you're going to want multiple layers of security, right? Having just one layer of security is not enough. You want to make sure. Again, thinking about a full stack application from database to server to front end to the user interface, you want to have multiple layers of protection. So at your user interface, if I have a password or if I have a field that says enter your email, well, I want to make sure that they enter it correctly right then and there. As in, I want to verify they have the @ symbol, whatever format I'm looking for should be done in the user interface. Additionally, like in my server, I should also have a check to make sure that the format is correct. Because for whatever reason, what if the UI broke or wasn't correct? You want to have some fail-safe that says, okay, whatever the UI sent me this data, let me verify that this data is correct. And then additionally, when you're finally inserting your data into the database, your database should also have some checks in place, ideally, so that you don't insert bad data. And your database is the sole authority of the data, so that check needs to be there. You don't want to insert bad data, even if it gets through like the first two layers. Anyway, so that's data security and integrity. Databases are really good at offering protection there. All right, what should be your design goals? So obviously you want to create multiple tables. We don't want to just have one table to have all the data we're storing. That's usually not the best approach. We want to have modular sections where if we have students should have their own table that's separate from classes, that's separate from addresses, for example. Also makes it easier to access data. We want to model proper relationships. So database tables, relational databases offer this ability. And then we talked about this earlier with our examples, but we want to reduce duplicate data. So going back to our school example, we talked about, we could just have that class ID as a part of our student records or in our student table, but that's going to lead to duplicate data, because if a student's enrolled in like 2, 3, or 7 classes, well, the student table, if we design it the poor way, which is having a class ID as a foreign key, we're going to have to repeat that student information each time that enrolled in a new class. So again, proper database design should be reducing duplicate data. All right. I think Tom talked about this on Monday. I'm just going to reiterate it. The general steps to take, nothing too crazy going on here. But step number one, make sure you take time to think about your design. Don't rush into it. Don't say, I'm just going to go with this. If it breaks, I'll update it later. No, take the time up front to have a proper design, because in the real world, it's much harder to modify databases after they're kind of up and running. Once you kind of have a good design in place, again, I highly recommend sketching out a design using one of those diagramming tools. I'm a visual person, so that benefits me. You might, you individually might learn differently, but just have some way where you can, justify why you created this design, right? We talked about this in OOP week, where, design can be subjective, but make sure you can back up the reason you chose this design over something else. So if I asked you like, hey, why did you create your table with these records? You should be able to say, well, this is why, this is our use case, this is what I was envisioning with our data. Once you do create a good design, first, I'd say create your entities, which are also known as just your tables. And then after you create your entities, models, we're going to be using that term a lot, especially when we come to Django. So models, just another word for tables. But once you create your tables, you want to create the relationships between your tables. All right, so 3 steps, pretty simple to understand, but again, the hardest part is about the thinking part. It's going to take probably the majority of your time. 2 and 3 is just kind of writing proper SQL queries and fixing syntax errors as they come. All right, let's talk a little more and we'll dive into an example. So let's talk about constraints. We've talked a lot about these, so most of this we'll review, but there's 3 main types of constraints you can have. You can have a primary key, and pretty much speaking for a relational databases, every single table is going to have a primary key. Right, so primary keys is just a unique way to identify records within a table. You can also have something called unique keys. We haven't talked too much about these, and what I have in parentheses are just nomenclature. That's what I use. I don't know how prevalent they might be, but when I'm naming a primary key, I name it PK underscore and give it a name. For unique keys, like say UQ, that's a key that enforces uniqueness. I'm kind of mixing terminology here, so I'll be upfront about that. There's an idea of adding constraints. So you would add a unique constraint to a table or a column in your table, and that's going to create a unique key behind the scenes. So again, constraints and keys aren't exactly the same thing, but just know that constraints are enforced by keys existing in your table. So unique key is going to guarantee that a particular column or columns are going to be unique to that table. And we're going to see an example why, why we might want to use this type of constraint. Foreign keys, we'll talk about them in detail a bit, but basically it's a key that references a key from another table. The key thing here, pun may be intended, is that this can be either a primary key or a unique key in another table. So you don't always have to reference a primary key. You just need to reference something that is unique. So that could be a unique key or primary keys. Primary keys effectively are unique keys, but they are the main key used for a table. Versus a unique key is not necessarily the way you'll identify something that is unique, but it's something that you want to be unique within your table. I know that's kind of maybe hard to understand, but we'll see an example of it. Again, just to reiterate, keys can be made up of multiple columns. You're not always mapping one column to one column all the time. You can map 2 columns to 2 columns also, or multiple columns, multiple columns. All right, so those are types of constraints: primary, unique, and foreign. We talked about types of relationships. So again, three main types. There's one-to-one. So let's talk about Facebook. So Facebook, I'm not a huge fan of their company, but it seems like we use them for examples often. We'll maybe use to update this. I'll probably try to update this for another example. But Facebook is generally easier to understand because I assume most of us have either have a Facebook account or have had a Facebook account or know just generally the platform. So Facebook, you might have users and you might have a separate table for profiles, right? User would be like maybe a username, password, and maybe email. A profile might be a little more detailed, like, maybe you might have your profile image, you might have, your tagline or whatever, Facebook might offer. So in this case, you might have a separate profile table and a user table. In this case, you're going to have a one-to-one relationship, meaning that a user can have at most one profile, and one profile can only be tied to one user. Now, this is kind of ignoring business pages and maybe, I don't know what else Facebook offers. Let's assume these are personal accounts. A user is not allowed to have two profiles, right? I can't have two different profile pages for one Facebook account. Likewise, if I have my personal account, I can't share that with someone else. There's no like spouse accounts or family accounts on Facebook. As far as I know, again, Facebook might have added that at some point, but generally speaking, it's gonna be a one-to-one mapping. All right. Typical case, what we've seen very often is the one-to-many case. So example, each Facebook user can have multiple different posts, right? I can post, today what I had for lunch. Tomorrow I could, post a picture of my new sneakers that I bought. So one user can have many posts that they create. However, one post cannot have multiple users. So this is why it's only a one-to-many relationship. So a user can post as many as they want. So I can have 20 different posts in a single day. That is fine. That is my one-to-many, as in one user and multiple posts. But that post can't have 20 users on it. As in, sure, users can comment on it, but there's only one author for that post. There's no co-authoring or anything like that. So that's a one-to-many relationship. Many-to-many is the idea of both sides can be multiple. So posts can have many expressions, and the same expression can be used by many posts. Term expression I'm using as like reaction or whatever. If you know Facebook, the like button, or whatever reaction you want to add, you could add a heart symbol, you could add a thumbs up, you could add a sad face. There's a few emotions or emoticons you can add to react to a post. So that's what I'm calling expressions. So if I post something like, hey, here's a picture of my new sneakers, Michael might kind of just like thumbs up it. Maybe, I don't know if there's a dislike, maybe a thumbs down, but yeah, Pink might be like, I don't like your sneakers, gonna thumbs down it. So again, my post can have multiple expressions tied to it. Likewise, the same expression can be used for many different posts. I can like, Jason's post, and then I could like Jonathan's post. I could like, Kana's post. If she has multiple posts, I could like different posts with the same expression. That's the same expression, which is like the thumbs up for different posts. So in this case, it's a many relationships. I know I've been kind of talking a lot here, so let's take time to kind of digest these three types, kind of envision, understand when you use a one-to-one versus a one-to-many versus a many-to-many. I'm going to pause here, digest that, and if you guys have any questions, let's make sure we discuss this.
I have a question.
Yep.
Little hypothetical. Let's say, for instance, you were enrolled in a coding boot camp, and there was this challenge that you had to create a Grubhub design, right?
Hypothetically speaking, yes.
The Grubhub, the way that works would be like you would have just taking like the restaurant, handling the restaurant portion of it. You might have multiple restaurants all in a specific delivery area that are the same restaurant, right? So they would have different addresses and other different information, like maybe store numbers and stuff like that, but they might share the same menus.
Okay.
And they might, share the same prices for those items and those menus and stuff like that. So how would something like that be handled when you have like a user class, the person who's actually handling like the delivery and the customers? Then you have a table that handles maybe your restaurant names and addresses, but then all of those different restaurants might be reverting back to a singular menu at some other part of your database.
Sure, let's actually explore this. Always good to have an example. So again, I like seeing the visual of this, so I'm just going to map this out. So we're going to go with the Grubhub example. This is, I think, one of your challenges, but let's kind of just do it rudimentary. I'm not going to do maybe each part of it, but I think Michael introduced the idea of restaurants. Honestly, I'm a terrible spelling. Is it A-U or U-A?
A-U.
All right, see, yeah. So there's a reason I went to like programming is because it's more math-based than spelling-based. So A-U. Restaurants. I think that's right. All right. Okay, so we have restaurants. Again, I'm not going to add too much data, but let's say they have an ID and a name. Guess we got fine. We'll give it types. I don't want to spend too much time on this, but hopefully you guys kind of can assume the types based on what we're going for. Int PK, I guess. Okay. So we have restaurants, and then Michael also mentioned menus. So let's say we have menus. What else we had? We had food items, so let's call them food items, right? And then he said restaurants, you might have like a chain that has different addresses of the same name. So I'm going to create an addresses table, similar to how we did with our student example. It's going to ID and then, or let's, whatever, the location. Am I going to get too detailed with the fields? You guys can hopefully assume what I meant. Okay, so this is our situation. So let's think about, how we map this out. So we have restaurants. Let's say we have, McDonald's. They have several different locations in this particular city. So in that case, I'd probably create restaurants location table. So this is the idea of a many to many. Why am I going many to many? Well, let's think about it. One restaurant, like McDonald's, we're just thinking franchise, can have multiple locations. Can multiple locations be mapped to one restaurant? No, so I guess I probably don't need this many. So addresses. So again, yeah, many is not the answer there. It looks like we probably want a restaurant ID here. So again, I'm kind of thinking about this design as we go, but thinking is the hardest part of this schema design. So I'm thinking one address can be used by only one, one restaurant, right? We can't have 123 Washington Street and have it both like a Panera and a McDonald's there. And we're assuming we're not having like, skyscrapers that have the same address. You have like individual store addresses too, I'm assuming here. So we're saying each address can be mapped to at most one restaurant. So that's why this is going to be a foreign key. So I forget the syntax here. It's FK restaurant, FK, and then restaurants. All right, so what we're saying here is one address can be mapped to one restaurant, but again, one restaurant franchise can have multiple locations. So this is a one-to-many relationship. All right, so we map that. We talk about menus. So each restaurant's going to have the same menu. So if we have McDonald's, the menu for McDonald's will be the same no matter what. So that would be a one-to-one relationship. With this diagramming tool, it's not easy to kind of reflect that. There is syntax here, so this is technically a one-to-many. One-to-many. All right, so this is saying a restaurant can have many addresses, but one address can have only one restaurant. So if you look at the docs here, again, this is the best way to do it in Postgres, but you can have different types of relationships. So you have one-to-one, one-to-many, many-to-many. We haven't talked about these, but they're
for the purposes of this example, you would have a one-to-many relationship for the restaurant to the addresses, and then like a many-to-one for those different restaurants by address to the menus.
So the menus we tie to the restaurant, yeah. So we have a menu. Let's just assume each restaurant has one menu. I guess we could add the menu to our restaurant directly. Sorry, are we saying one restaurant can have multiple menus, or one restaurant has one?
No, I was saying that all those multiple addresses, instances of that restaurant would have essentially the same menu, right? So that would be, I'm trying to figure out what the relationship would be and how you would structure it. Would you be like a many of those restaurants by address to one relationship for the menu, or would you link the menu by restaurant ID? That was really the part that I was caught up with that particular challenge. That's
gotcha.
why I
Yeah.
asked.
So in this case, again, it comes down to our requirements. I'm assuming that one restaurant franchise, so let's just go with McDonald's, can have multiple locations. So that is why we set up a foreign key here. So each address can't be reused, but each address can map to the same ID. So again, I might have like 123 Washington Street, 456 Randolph Street. Both those might be referring to a McDonald's. So in that case, this is a many to one, as in McDonald's can have many different addresses, but one address can only have one restaurant it's tied to. So your question of menus, yeah, menus won't be address specific. So I'm assuming that each McDonald's has the same type of menu, but maybe let's say they have like a breakfast menu and a full menu. So in that case, we create a separate menus table and then tie that to a restaurant ID. So in this case, we have restaurant ID here. Restaurant ID, restaurant. Okay, so menus would be a separate table that kind of ties back to a restaurant because we're assuming we'd have multiple menus. If we didn't have multiple menus, we could probably just do a menu ID here, meaning that McDonald's has one and only one menu ID, and then that could reference the menus table. So this would be a one-to-one foreign key. Menus.id. All right, so again, it all goes back to your requirements. In this case, if I went this way, I'm saying a restaurant can have at most one and definitely needs one menu here. So the menus will just kind of detail what food items we have. So this should just be a name of the menu, and then we need probably a separate table. I know I'm going kind of quick here, but hopefully the ID is conveyed. If not, we can talk about it more. We'd have a join table here where, or if food items can't be reused, we just simply have a menu ID here. So again, if tacos, tacos can only be on one menu, we'd have menu ID here. Assuming tacos can be on McDonald's menu and Wendy's menu, we might want to have a menu food items join table, because this is going to be a menu relationship, meaning here we'd have an ID for the table, we'd have a menu ID and a food item ID. Now the reason I went with this is because, again, if we go with tacos, tacos is things, let's go with French fries. We have a food item stored in our food items table called French fries. The reason we have a join table is because, well, Wendy's, which would be a restaurant chain that we create in our restaurants table, and then McDonald's, which is another restaurant, they both can have French fries on their menu. So in that case, we tie those together by having the food ID of French fries, the menu ID of McDonald's for one record, and then a separate record would have food ID French fries and menu ID for Wendy's menu. Again, I guess there's an intermediate menu here, but this would be tied to a restaurant. So we're kind of just jumping between tables. I know that's getting kind of confusing. As I try to flush this out, any questions about anything I just kind of yelled out there?
So these relationship types that you just talked about, is this something we have to expressly tell the computer to do, or is it just something to think about while we're designing?
Yes and no. Yes, you're going to have to model it correctly. And depending on the type, you're going to have to tell Postgres how to reflect it. So I think that's a good transition to our next slide. How do we create these in Postgres, right? We're just doing a diagram here. This isn't really SQL code. It's just giving us a visual with like all these strings going around here. How do we actually create one-to-one, one-to-many, many? Answer, we use our constraints that we talked about earlier. So if you want a one-to-many, one-to-one, sorry, you need to create both a foreign key and a unique key. So this is kind of the harder case. You're not going to see one-to-one relationships often, but if you need that, you need a unique key in addition to a foreign key. One-to-many, I think we've been doing this pretty consistently, but if you want a one-to-many relationship, simply add a field and then create a foreign key relationship, meaning you're referencing some other table. So this is not limiting to one instance of it. So for example, if we had restaurants and addresses, well, we would add a foreign key to the addresses table referencing a particular restaurant. But we're not limited to have one address to one restaurant, right? We could have many addresses for the same restaurant franchise. So that'd be a foreign key where we create a field in the target table, in the source table, target table being addresses, and that's sourcing data from your restaurant table. So your target has a field, you create a foreign key that points to your source, in this case, restaurants. Finally, we have many relationships, and the way we model these is through creating a brand new table, and that's often referred to as a join table or a through table. So yeah, make sure you understand when you need to create a particular relationship, what you actually need to do. All right, so as always, I think going through an example, so we're gonna go back to Facebook. Let's actually kind of model this out and try to create some tables in Postgres with the time that we have here. So I'm gonna go with Facebook, so let's go to our diagramming tool first. I'm gonna delete all these. Let's create some tables. First, I'm going to create users. Let's have an ID. I said username will be a field, maybe email, say password, and I guess email and username might be the same, but let's assume Facebook lets you create a unique username. So email will be my fields. Let's create a profile. So it's going to be, let's say, image URL. You'd also have like a background image if you're familiar with the layout of Facebook. So background URL. This is the ID. What else can you have in your profile? Let's say tagline, and let's say that's what your profile is. Yes, we could put this information in our user table, but again, I'm kind of breaking this out into smaller bits. Even though this is going to be a one-to-one mapping, I'm deciding I want this to be kind of separate from users. So let's say, maybe not all users have a background URL that they want to care about. Like that, I don't want to kind of clutter up my users table. Is the reason for this design decision that I made. All right, we have profile. Let's go with our main items. So posts. User can make a post. So this would have a user ID. And then we have expressions. So this is going to be ID and expression type. And finally, we're going to need a join table because, as we mentioned, expressions and posts, that's going to be a many relationship, meaning one post can have many different expressions, and then one expression can be used across different posts. We could say post expressions as our join table. So we'll have an ID, and we'll have a post ID, expression ID, and then we also want to know who is making that expression. So in this case, we'll toss in user ID here. All right, so I'm just creating my data. I'm not creating relationships right now. I am kind of thinking about my relationships, I guess. So maybe kind of do this in tandem, but all right. So we have users, we have profiles, which would be plural, posts, expressions, and post expressions. All right, so I've created my data. Now I want to create my relationships. So with this tool, it kind of makes it kind of nice. You can use the GUI to kind of do this. So let's see, looking at my profiles. Oops, I don't want to do that. I need a user ID here. Looks like I missed the field. All right, so that user ID, this can link to users. So I'm just going to drag it. That will connect those. This should be one-to-one. So by default, they create a one-to-many. I want that one-to-one. What else? So looking at posts, posts have a user ID. They probably have content. We just don't have a blank item, but user ID will map to ID. So notice this is a one-to-many. I started in my post table and drag this connection. So it's kind of hard to see, but look at the branches here. Notice that there's like 3 branches where I'm kind of circling here, right here. That is kind of just depicting a one-to-many. And this goes into ER diagrams, entity relational diagrams. But this is kind of shorthand telling you, hey, there's a slash here. That means this is one-to-one versus this is 1 slash here. There's 3 branches here. That's a one-to-many. We're not going to worry too much about ER diagrams. Just want to point that out. All right, so we also have content. That's not referencing anything. Post ID. Yep, this is going to tell you the post ID. Expression ID will be expression. And then user ID will be, oops, I'll drag this. Okay, so again, we got the spaghetti model here, but kind of showing the relationships between our tables. Any questions about these relationships? Again, the highlight here is this many-to-many. This needs to exist because of the relationship between expressions and posts. Again, posts can have many expression types. One expression type can be used across many posts. So that's why we need this table here. All right, so this is kind of what my diagram will look like. So we have a one-to-one between profiles and users. We have a many-to-many between expressions and posts. And then we have a one-to-many for users and posts. That's going to be our 3 examples we're going to go through. Was there a question out there, Yipping?
Yes, I have one. So do you need a relationship between these users and posts? Because you already created the relationship between them through the post expressions tables, right?
Good question. So this is where it gets kind of confusing. This user ID is not the same as this user ID, meaning when I create a post, that is where my user ID is going to be, when I'm the author of the post, versus when someone reacts to the post, that is what this user ID is for. So I write a post, let's say, hey, here's my new sneakers. I really like, this brand. If you're reacting to that post, that's where your user ID is going to be. So this user ID is saying, hey, someone's making a reaction. Well, how do I know more information about that user? Well, I'm going to look at the user table. This user ID is the author of the post. This is the kind of the author of the expression. Yes,
okay.
they are referencing the same value, but again, this is a different use case. This is author ID. This is expression author ID, or whatever you want to call it. But yeah, I've had that question also. Well, we have kind of like this triangle here. Why do we need it? Well, in this case, this user ID and this user ID are not the same. They can be the same depending on your use case. In that case, you can kind of disconnect them and look up values through two different tables, but we're not going to get to that today.
So is this an instance though where you'd want to be more specific on that, being
like the name of it?
Yeah.
Yeah,
like
it doesn't hurt. It never
expression.
hurts to be more clear. So yeah, let's kind of go with an example. Let's say expressionists.
Would it be easier to go the other way around with the post, make it the author ID or something like that?
Yeah, again, we could modify both. Always good to have good naming. So this is probably a good example. Hopefully this makes it a little clear. Expressionist, user ID, author ID. Hopefully that makes it a little clear. We can also put like user profile ID, but I'm not going to go that far. All right.
Just so I'm clear, the value that's actually stored in expressionist user ID is going to be the user's ID though. Isn't that correct?
Yes, the user that's making that expression. It has nothing to do with who authored the post.
All right. But so let's say given I had a post expression, I could then dig into that post expression on that post expressions table and get the post ID of that expression, right?
Yes.
So I could connect the dots to the post via post expressions from the user, if that makes sense. Like, since I have posts, since I have the user ID, the connection between users and post, I can make the connection there. Or if I just had the post expression, I could find the user ID for that post. Is that correct? Or it's just giving me more options of where to pull up that user's information?
Yes, I think so. So if you're saying, Michael, let's say you're only given a post expression record to start with. Yes, let's say we start with the post expression and you want to know the author of the post that you reacted to. Well, the way you would do that is not through expressionist ID, because that is referring to the person that made the expression or the reaction. In this case, yes, you would take post expression, look at the post ID, and go like, okay, that's going to give me information about the post. Within that post that you get back from the post ID, then you have access to author ID. So from post expression, you go to post table. From that, you take author ID and go to users table. That will give you the name of the author. For example, if you want the username of the author, that's how you kind of go through two tables to get the information you want. Let's actually kind of code this up quickly and maybe see an example of a few queries. I know we're running short on time, but let's try to get this going. So I'm going to copy the pseudocode here. And then let's go to my coding editor. So I had all this before. Let's get rid of it. Bye-bye, bye-bye, and bye-bye. All right. All right, so let's drop in our pseudocode here. And looks like I lost it. Copy, paste. Oh, that works. All right, select all, comment that. All right, let's kind of try to model this through our SQL. So I'm going to create table users. So for my semicolon, let's just drop these in here. All right, so ID is going to be serial primary key. And username will be varchar64. Password will just be, again, normally we don't store clear text, so it's be hashed, but I'm not going to do any of that, obviously. But it's still going to be varchar, regardless of hash or not. And then email can also be, say, 128 in case you have a long email. All right, that's my users table. Simple enough. Let's create my profile table. Profile's going to have these fields. All right, so we had the user ID will be foreign key. I guess let's just do it inline references. All right, so this is our one-to-one example, and we'll kind of detail that. So this is, let's just mark it 1, 2. All right, this is only half the battle. This is going to set up a foreign key, which is a one-to-many. Question is, how do we make this one-to-one? Varchar 64. I don't know, that's a URL, probably one longer. Let's say go 1024, sometimes you get some messy URLs. And then tagline can be, let's go with text field. Just change it up, text. Okay, so that's my profile. Let's go with create this quickly. So create table, posts, and then we have 2 fields on there. Content, which would be our text field. And author ID, which should be an integer, references our users table. We also have an ID. Again, every table is going to have a ID as the primary key. All right, so ideally I want to create some data that we could reference. So hopefully I could do that in short order. Expressions. As I'm typing this, any questions that popped up? Let's kind of try to multitask here. Okay.
Yeah, I got a quick question.
Go for it.
Just like functionally, when would be like, is what the difference between varchar and text? Like, is there a different functionality of when I would use text as opposed to varchar?
Yeah, so varchar has limitations. It might be different based on what flavor of SQL you're using, but I think for Postgres, I Googled it, it's like 1 million characters, right? The limit of varchar in Postgres. Usually speaking for short text fields, so it says 1 gigabyte. Usually speaking for short text fields like name or email address, I would say use varchar. You want to use text when it can be like paragraphs. So let's say if you have a lot of text, go to just the default to text. Again, varchar can probably handle it if you want to just have like, you know, 1 gigabyte, you could use varchar apparently. But I'll just say if it's like a long response, use text. If it's a short answer, use varchar will be my recommendation there.
Okay, thank you.
Yep, thanks for your question. All right, let's get this final table going, and then let's try to answer some data. Let's try to do some queries if we have time for it. So we're hitting noon here, so definitely want to be respectful of your lunchtime. So let's kind of wrap this up. Tab, that's foreign key, so it's going to be integer. All right, so post ID should reference posts ID. Again, our main goal here is to kind of reflects on one-to-one versus one-to-many versus many-many, how we implement them in Postgres. So this is our post expressions. This is our join table for our many-to-many references, posts ID, expression ID, and then finally we have this one, integer, references, users. Okay, I think that's everything I want. Let's kind of talk about it. So again, we just modeled what we kind of drew up here, right? Kind of all these relationships. We have the foreign keys in there, but the one-to-one requires one additional step. So let's kind of just create this as is and create some data for it. So let me quit with this. Is there a comment there?
Yeah, I think your first and second tables have the same table name.
Can't get anything by you guys. You guys are good at catching mistakes. Profiles, posts, expressions, got my commas. Yeah, a comma there. Okay, hopefully I didn't mess up anything. So this is an example of one too many. All right, let's create a new database. So clear my terminal, create DB. Let's call this Facebook. Okay, let's run my schema file on that. So I'm going to do piece equal Facebook. We get my schema file. All right, cool. No errors. I'm actually surprised because usually I always have one error. So we created 5 tables. Again, those 5 tables are profiles, users, expressions, posts, and post expressions. Let's try to insert some data. So let's go to our data file, insert into users. We had was it username, password, and the last one, email. The values. Username. And email will be. Hopefully that's not someone's email address, but I bet that is. Anyway, we'll insert that. Actually, is there a way to insert multiple values at once? I believe there is. Insert multiple values Postgres. Yep, you can just chain the values like this. So that's quite handy. Since we want to do multiples, we should be able to do so. So add a comma here. All right, let's add just like 3 users. I'm not gonna get too crazy with it. I'm not gonna add 5 billion users or how many users Facebook has. Say Mark Z, password would be hates Twitter, and this would be Zuck. All right, one more user. Let's go with Brian. Since we chatted, we'll have Brian pass the username. Brian, what's your password for your email?
I ain't telling you.
I ain't telling you. It's a long password, but I guess it's secure. I ain't telling you. And then let's just say Brian's Brian. Let's say he has got a code Platoon email address. All right, so we have our users. Let's create a few posts. I guess we need profiles also. So let's create one profile. I'm not gonna get too into it. So into profiles, what are our fields? We had image, URL, I need a refresher. Sorry if this is kind of tedious. Maybe we could have done this ahead of time, but let's just power through. So we have background URL and tagline. This is kind of like if I'm required from Python. I can order these in whatever way I want. So against the ordering here, I need to match that with what I'm putting here. So again, I'm putting this in order of how I define them, but I don't have to. I could swap, whatever I want, as long as they're matched up. Values, let's actually swap them just for fun. I guess I have a different definition of fun. We have tagline, background URL. So we're going to insert values. Let's just say this is going to be whatever, HTTP www.donuts.com/best.png. I guess it's probably not my image URL, so image URL will be whatever .jpeg. Tagline, I like donuts. This is a weird profile, but we'll go with that. All right, so we have that. I'm just gonna create one profile here, so for example. So let's see what happens here.
Do you need a user ID?
Yes, I do. Thank you. Schema, user ID. Thank you. So that would definitely cause us an error. So user ID. Let's assume user 1. So we're going to assume fun username is going to get user ID 1. So I'm going to kind of automatically assume that here. So create my semicolons. Let's run this quickly. So I'm going to do pSQL Facebook. Fingers crossed, no errors. Data.
Is it because they're double quotes and not single quotes? It's
Ding,
trying
ding,
to.
ding, 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 I think. Yes, Seth hits it on the head. I totally forgot, but yes, double quotes and single quotes are not interchangeable. Good lesson here. Accidental lesson. How do I replace? Mention. Edit. All right. So we want to find double quotes and thank you. Yes, good point there. So use single quotes. Lesson learned. Hopefully. All right, there we go. So we inserted 3 records. Thank you, Seth, for users and 1 record for profiles. All right. The question here is, I wanted a 1-to-1 mapping, right? If you remember from our design discussion, 1 user can have at most 1 profile, and 1 profile can only have 1 user that's associated with. Right now, I've not enforced that, meaning I can insert a new record. Excuse me. I can run this again. Let's actually just run it in our terminal. I run this again. Let's change it to I hate donuts. It's probably there's another URL for the profile, but let's go with that. So I insert this. Notice.
I think you have to be in the SQL.
Yeah, sorry, I am thinking faster than I'm typing. But I'm glad you guys are here to help me. All right, so I'm just going to change a few fields to make this a little different. I hate donuts, and this can be some other JPEG. This guy's semicolon there. All right, so now we have 2 records in our table. So if we do select star from profiles, notice that this is not what we want. This is not a 1-to-1 mapping. We have 2 profiles pointing at the same user ID, and our database let us do it. We need to enforce this. And the way we need to do this is by adding a unique key, right? Remember from my limited slides here, we need a foreign key plus unique key. What this unique key is going to do is it's going to exist on our profiles table. So this is saying this user ID should reference something that exists there. But we also want that to be unique. So we can do an alter table. We're going to add a constraint, similar to how we added a constraint for, sorry, I can't type and talk at the same time, apparently. Alter table, we want to alter the profiles table. I want to add a constraint. We're going to name that UQ user ID. What this is going to eventually do is going to say, we should never see the same user ID in this profiles table more than once. That's going to guarantee that each entry is going to have at most 1 user ID that it uses from the users table. It doesn't have to use every user from the users table, but we could never have duplicates here. So we're going to add constraint, unique field name will be user ID. I think in parentheses. All right, so we're going to alter table, add a constraint, and make sure that this is unique. So assuming I made no errors there, which isn't always given, I'm going to copy this, run that in my shell. Okay, so notice that I was unable to do it because I already have something that's duplicated. So this is where I might want to update my data record before doing it or dropping a record. So let's do a delete. So delete from profiles where tagline equals I hate donuts. Semicolon. All right, now we should be able to actually insert our unique key because that's not going to be violated. So if I do my Control L, right? So this is gonna add a unique constraint. Great. So notice alter table successful. So now if I try to run this again, notice I'm referencing the same user ID here. If I try to run it, this should protect me from having a duplicate record with the same ID. Sorry, a duplicate user ID. So if I run this here, notice we get a violation. We are not able to do this. So again, combined with a foreign key, a unique key and a foreign key gives you a one-to-one mapping, meaning you can never have the same user ID used in your profile table. Again, the foreign key gives us the one-to-many. The unique key shrinks that one-to-many down to a one-to-one. All right, so again, you're not going to be seeing one-to-ones very often, but it is something that you might have to do, and just know it's possible with a foreign key and a unique key. We've talked about foreign keys probably a lot, so I'm not going to go into detail there, but basically each post is going to have an author ID. But again, I could create multiple posts, meaning there could be like 7 different post records that have the same author ID. That's totally fine. We don't need to limit that to one-to-one, right? But the expressions is expressions and posts have a many. So let's create a few data records, and then I'll get you guys lunch, I promise. Insert into posts. Let's create a post quickly. Grab the values. We want author ID was one value, content was other. That's all we needed. Values. I'm just gonna make them all my author. So one will be hello. Let's say make another post. That's 2, goodbye, and 3 will be what's for lunch. All right, so those are my 3 posts. Let's add one more. Oh, sorry.
Maybe just the single quotes.
Yes, I keep making this a mistake. I'm a double quote.
And also, I had a question. So, could you show us for like could you show us like the easiest way to access like I guess the first name or last name of the author of any particular post?
Yes, so I'm going to do that once I enter the data. But yeah, stay tuned. So let's add one more record here. All right, let's say user 2, which is Mark Z. We'll say I own Facebook. Okay, so we're going to insert 4 posts. Let's create some expression types. Again, these are just types of expressions that can exist, not any ones that are attributed anywhere. So expressions will be type. Values will be, let's say they're strings, so we'll have a like, and then we'll have hate. I don't think Facebook has hate, but I'll introduce it. Funny might be a reaction. Let's do sad, and let's do one more. Let's do angry. I think angry is one. All right, so those are going to be our types. So now we have that many relationship. So let's create these 2 tables. Or these values. So on that. Cool. No errors. And then here, no errors. Values with an S.
Expressions too.
Typos galore. And that's why I like writing in this file, so I don't have to work with the command line as much. Right. Oh, did I use a? Did I accidentally use expression type? Yeah, I might have used a reserved keyword there. Expression type. Okay, so we inserted 5 expression types. Let's quickly do some join table entries, do a query, and then hopefully get your lunch. I know you guys are hungry. So insert into post expressions. All right, so this takes in 1, a post ID, 2nd, an expression ID, and then what do I call it? I forgot the naming for it. Expressionist user ID. Okay, so those are our 3 values we need to insert. So values, let's look at our posts again. So post ID, post 1 is going to be hello. So let's say Mark Z is going to like that post. So expression ID is going to be, this is ID 1. So we'll go 1 there. And the user ID of the person creating that expression is 2. So that's Mark Z. So again, I kind of have all this up here. Right. So again, I'm inserting this and assuming they're going to get the ID 1. I can't guarantee that all the time, right? already have some posts that exist. This is not going to get ID 1. It's going to be the next available ID. But in this case, I don't have any posts additional I'm going to add in here. So post expressions, and this are a bunch of IDs, but that should give us access to the other tables if we need it. Let's add another thing. Let's say 1-1. So my post again is a popular post. Let's say user 3 likes that also. Let's say Mark Zuckerberg's post, which is post 4. Let's say I'm responding to it, and let's say I hate that post for whatever reason. So we'll do it too. All right, let's insert these records, assuming that they go through. Bring up a terminal. That's that. And get into my shell. Facebook. Let's run that. Okay, so now we have some data. Again, probably hard to visualize it all. I'm kind of just dumping a bunch of data here, but let's say I want to query. I want to know who liked my post. I want to know the name of the person that liked my post. All right, so I'm going to go to my queries. So let's say I know which post I want to deal with. So let's say select. What's the ultimate thing I want? I want the username of the people that like my post. I'm going to do select username from users. All right, so let me actually write out what I'm trying to search for. So I want to know the user names of the people that liked my post with content of one. All right, so I'm going to specifically look for a post that I wrote that had the contents of the hello. I want to know who liked it and display their usernames. So it's going to get kind of complicated, but let's try to piece it together. So eventually I want to return the username of the people that like my post. So how do I know which post I care about? So let's do a join on, let's go with post expressions, name that PE on, it's going to get a little complicated, but stick with me. Let's do P dot post ID equals all right, so we're going to match post expressions to the posts, where post dot so we need a where clause. So we need to join this where sorry, I'm trying to struggle through this. So where p dot content equals hello and u dot p dot p dot author ID. All right, this can get kind of complicated. I might do it incorrectly. Let's try this out. So author ID equals user ID, and
Is
right,
P aliasing posts?
yes. So what I'm saying here, my criteria, so you kind of work out backwards. I want to find, I know my ID. That's a given. That's what I'm just assuming I know, have data on hand. My user ID is 1. So that's part of the criteria. I want to look for a post where my content for that post was hello. So that's the criteria of what I want to match. Based on that, I want to find all the expressions that tie to that post that is found. And then from that, eventually I want to get the user ID. So I need to also do, let's see. So we have pe.user ID. We need to use that as another join, I believe. So we'll join users. v on pe dot, so v dot user equals pe dot expressionist user. All right, so we have two users table, but one table is referencing, the expression ID. Sorry, I'm getting lost here. User's ID. Okay, so this should be pe dot expressionist ID equals ID. All right, so we want to match every expression that is tied to the user. All right, I'm gonna give this maybe 5 more minutes and then we'll break for lunch. So we want to get the username. That's what we want from users. So this needs to join on expressions. On e dot ID equals pe dot expression ID. So we'll link those together, and then that's gonna be part of our condition. And e dot expression type is a link. Right, because we know liked. We don't know the ID of liked. So that's part of say user. Right, so we know the type we want, so that's why we are matching the type from the expressions table. We need author ID here, so this should be p dot author ID, should be my ID because I'm the one that wrote the post. I want the post that has the content below. I want to know the expressions that were liked, and then based on that, I want the username. So let's actually try this. I might need to tinker with it. Let's try running this. So control command Q, clear, and then we'll try to break it down because it is a complicated query. So if I run pSQL Facebook queries, okay. Oh, double quotes again. I am going to make that mistake over and over. Hopefully one day I'll learn. So hopefully you guys are learning from my mistakes. Use single quotes. Don't be like me. Author ID. So I want E type. I think I misnamed it. What did I name it? It's expression type as well, not type. Always good to know what columns you're working with. So this should be expression type. All right, I got 0 rows. That's not what I want. So let's break this down. We're taking post expressions, the user that made the expression, we're mapping that to our user table. Oh, this is the mistake here. So we don't want that. We want to join p.author with p. Let's see. So can we join without an on? So we need to introduce our post table. All right, so the post ID should be from our post expressions table. So again, as you can kind of see, like it takes a while to kind of chain them all together, but I think this should be the correct answer. So again, you need to figure out how you're actually accessing each table. So we're starting with our post expressions table, and then we're basically mashing up expressions so that we can match the type. We also want to get the post so that we can get the author ID and the content. This users table is required because we are looking at the user expression as user ID, eventually want to get the username. So I think this should be what I want. All right, there we go. So we get Mark Z and Brian S. The reason we get that is because looking at our data, both Brian, so this is Mark, user ID 2, gave us a like. So that is type 1. And Brian also liked my post. Well, if I enter a new record and say post 1, which is my hello post, let's say someone hated it, that's expression 2. Let's say Brian did this also. This gets into another question. Can the same user react to the same post with different expressions. For Facebook's answer, that's no. So we probably need to have a one-to-one mapping, as in we need a unique key so that essentially this should be post ID in conjunction with expressionist ID should be unique. So this gets into the idea of creating a composite or multiple columns for a unique key. So essentially we're saying post ID plus expressionist user ID. There should never be a duplicate of the same type. So we're saying one user cannot react to multiple posts. One user can react to a different post, but in conjunction, these two should be unique in this table. So if we wanted to do that, we could add an alter table, similar to what we did before. And we can, again, specify multiple columns here. So in fact, I'll just copy what I had before. So I was saying both of these in conjunction must be unique. But again, you could have duplicate post IDs in here, or you could have duplicate expressionist IDs separately. But again, in conjunction, that should be unique. So if I added this unique constraint, I should not be able to add another reaction from Brian to the same post. But in this case, I'm going to go with it because I don't have another user. So let's try entering that. Not in my shell. P-SQL, Facebook. Okay, so I inserted another user. All right, last thing I promise, and we'll get to lunch. All right, so let's enter one more user because this is not going to work like I wanted. Let's say Elon M. Password will be rockets. All right, so we have no new user. That user is going to be user ID 4. I guess I can't do that this way. All right, so that's Elon Musk. Semicolon. Okay, so Elon Musk is going to react to my post. He's going to hate it. So it's just showing that I'm not getting all the posts here. So if I run this query that I had before, Control L. Query here. So again, let's run this query just like before. So I'll do /I queries. All right, so notice I still get Mark and Brian. I don't see Elon here. If I remove this condition, right, this is specifically saying I only want the likes. If I remove that, notice how my result will change here. Notice I get Brian because I inserted in, how did I screw this up? My post hated. Did I not run this? Oh, I don't think I inserted this. Gotcha, thanks. All right, so going kind of quickly here. So I'm creating some things. All right, notice I get Elon here because I'm not limiting it just to likes. I said take any type of expressions in case, in this case, I don't need to join on an expressions table because I care nothing about the data in there. I'm saying just give me all reactions, whether they're hates, likes, or sad, whatever. But if I want that, I need to have what I kind of removed here. So p.expression type equals like. Let's say I want to see who hated my posts, right? That should let me know how I need to defriend, probably. Just kidding. But here I need expressions back on p.id equals pe.expression type. Right, so I want to know who hated my posts. Cool, I should be able to do that. PE expression type. Oh, this should be expression ID. All right, there we go. I saw Elon hated my post and Brian did. Again, Brian has 2 reactions to the same post. Normally, I would say for Facebook's case, we need to have this unique constraint so that Brian can't both hate and like my post, same post. He can hate one post, like a different post of mine, but he should not be able to react to the same post. That's where a unique key will come into play if we wanted to enforce that. Okay, so this is a complicated query. I'm going to table any additional discussions for maybe stand down today, just because I know we probably want to get to lunch. Before we get to lunch, let's take a look at the calendar because there's a few things on it in case you didn't take a peek. So 2 things this afternoon at 2 p.m. Matthew is going to be running a breakout session on SQL. So if you have additional questions, I'd say if you have questions on this, maybe just talk about a similar query. I could try to give Matthew my tables here in case he wants to kind of simulate this. But again, joins can get kind of complicated. Again, it took me a while to piece it together. I would use the diagram to kind of say, okay, I have this information. I want to get this information for this expressionist ID. Kind of bounce around tables. That's kind of how I visualize it. Second thing going on this afternoon, we have a Beyond Tech. So it's going to be John's personal finance part 2. So we had part 1 last week. So that's going to be at 4:30. So make sure you kind of keep this in mind. Your challenges are the same from the last 2 nights. Try to get through these 4, assuming you got through these 4 already. But again, if you didn't complete schema design, again, there's 3 different challenges. That's probably the longest challenge of all of these. Get through that. Try to do your SQL queries, get practice writing SQL queries, and then definitely do the tutorials. Don't neglect them, especially if you never wrote SQL before. I learned a lot doing the SQL Zoo. Like, I'm being honest. I went through it. I struggled through it, as in doing these joins. Some of these get really complicated. So I'm not saying they should be easy, but they should give you practice. So definitely give them a try. Okay, I know we went long. I need to get better about that, but let me stop recording here.